Okay, so we resume our lecture. So previously, we have discussed about introduction to biostatistics. What is biostatistics? The importance of biostatistics. And in this course, we are going to cover two types of statistics. The first one is non-parametric statistics, and the second one is parametric statistics. So in LU2, we are going to cover a couple of non-parametric tests. Okay, so it will be several tests. I think 1, 2, 3, 4, 5, 5 non-parametric tests that we will discuss. So today's lecture, we're going to focus on the first test, which is sign test. So that's what LU2 is all about. Okay. In LU3, we will discuss about parametric tests. So now let's move to today's outline. Okay, so it's about sign test. So under sign test, we are going to look at what is sign test and what is one sample sign test, right? And then left tail or two tail test, what is meant by that? And then some extra notes for one sample sign test when n is greater or equal to 25. So we're going to have a look at it, what is meant by that. And then second part is paired sample sign test. Okay, so that's the outline basically. Can you see the slide? It's a bit smaller than usual because I want to have the notebooks beside it for me to scribble. I hope it's readable. Okay. So sign test. So this is among the simplest non-parametric test. Okay. And it's among the earliest, I think, introduced by statistician. Okay. Basically, when we talk about statistics or any test in statistics, we are comparing things. Okay. We are comparing sample with another sample, sample with the population. So it's all about comparison. Okay. So sign test is a test whereby we do the comparison by assigning the signs. Okay? That's why it's called sign test. So the signs means here the positive or negative. So, but before that, let me introduce what is the sign test. Okay, it can be divided into two situations. Okay, uh, whether it's one sample or paired samples. So what is meant by one sample? You know, it's only one. The sample is one. So it can be that you compare, for example, let's say in the sample, right? There are many data, right? You know, still remember sample and population. For example, this is population, right? This is population. Okay, so it can be one sample sign. When we say that one sample, it can be like we compare each of the data in the sample, in that particular sample, with, let's say, the mean value of the population. So in statistics, we always compare the means, the average values, because the average represent the data, right? So that is an example of it. Another example is when there is one sample, but it undergoes two situations. Let's say in a case whereby um, a sample of students, let's say from student 1 to 10, right? But then we give two situations, right? Maybe what vitamins, let's say vitamins, yeah? Okay, vitamins, and what are the effects of the vitamins to the students on their study performance, for example, right? And we assess the performance in terms of exam marks, right? So let's say this is score before taking vitamins, exam score. Before taking vitamins, maybe. Okay. So because there are 10 students, there are various results obtained by that 10 students. So another situation is the exam score after taking vitamins, for example. Okay, so they have its own scores for all of these 10 students. So you can see that here it still referred to one sample, right? But it undergoes two different situations whereby each situation has its own data. Okay, so this is also considered as one sample situation. Okay, right. So I hope it's clear. So what is this sign test? I mentioned that it's about comparing, right? But what comparing what and how? Okay. So it's a statistical method to test for consistent differences between pairs of observations. When it says pairs of observation, is let's say here, you want to compare student 1. So here is student 1, right? So it has its his score or his or her score before taking vitamins and after taking vitamins. Let's say the marks is 70, and then after taking vitamins is 85 maybe. So this data, these two data is the pair of observation. Okay, you want to compare before and after. Yeah, right. So that is meant by this one, the pairs of observations. Yeah. Right. So it's about comparison. Given pairs of observations such as rate, pre, and post. Okay, I give an example already, but this is what is meant by the pairs of observation in two different situations, but referring to the same person. Okay. Right. So how are we going to compare? Let's say this one is 70, 85. This one is here the student 2 got let's say 60, 70, 85, 70, like that. Okay, so how are we going to compare? So if let's say we compare 70 and 85, we compare from the point of view of this, I name it like 1, 2. Okay, the first situation, 70 is less than 85, right? So we assign the signs the sign here as negative, okay, because it's less than 85. 60 and 70, 60 is less than 70, negative. But here, 85 and 70, 85 is greater than 70, so we assign here positive. So that is meant by the sign. Yeah? So that's why we call it a sign test, because we assign the signs, and the signs are in the form of negative and positive. Okay? Right. Positive sign is assigned to the data when it is bigger than the value it is compared with, and negative sign is assigned to the data when it is bigger than the value it is compared with. Okay, I've mentioned about it. So that is what sign test is all about, basically. But what we have to do next is, based on the signs, there are few steps after that, whereby at the end we want to make a conclusion whether data set 1, in this case, I go specific for this example. At the end, you want to make a conclusion based on the observation of each pairs of observation. You want to make a conclusion whether there is a difference or not between the data set 1 or data set 2, whether data set 1 is greater or less than data set 2. Okay. Or at the end, if let's say we want to focus on this situation, we want to say that whether the vitamin, it gives an impact or not on the exam performance of the students, right? So that is actually the ultimate aim, right? It's not just about comparing the data, but we relate to the subject matter. We relate to the point of the situation, right? In this case, is the effect of vitamins on the exam performance of the students. Okay, got it? Okay, so if you see here, we assign negative, positive, but we don't care about the values. Like it's supposed to be, if you want to consider the difference, the magnitude. The magnitude is the value, right? So we can say it's -5, right? This one is -10. But in this test, it is considered as a simple test because we don't consider the magnitude. We just consider whether it's negative, positive. Okay. So from one point, it is a simple test because you just put negative or negative, positive. But the downside or the limitation of this test is that it doesn't give much. Well, in terms of the strength of statistical tests, it is not a strong test because we don't have much information about how much data set 1 is different from data set 2, for example. Okay. So in statistics, there are many tests actually, and when you have studied all the tests and when you encounter a situation, it is up to you actually to choose which test you want to use, depending on the situation, depending on the requirement, the needs, and yeah, the suitability of the data to the test. Okay, so that's why we teach you different tests, different set of tests, and at the end of this course, you are expected to know how to use the test to analyze your problems. Okay, so if let's say this sign test is used if let's say you just want to have an idea about like whether or not let's say in this case whether or not the vitamin gives an effect. Okay, maybe you just want to know to that level, but if you want to know how much, perhaps this test might not be suitable. We have to go for a more sensitive test, which will be covered in the next lectures. Yeah. So if you see the non-parametric test, this is the first test that we are going to discuss, which is sign test. But it's not just the only non-parametric test. There are many tests. Not this one. So this one. Okay, this one. So you can see that there are many tests apart from this. So this is among the simplest, right? The simplest, and yeah, it's actually the easiest. Okay, so since we only concern with two outcomes, it's negative or positive, right? So there are two outcomes, positive, negative. So the probability can be said that, in any situation, it can be 50% higher, or I mean, the data can have 50% probability of being more, right? Or 50% of less, correct? If let's say you, what? It's something to do with you attend an interview. If you want to attend an interview, the probability is either yes or no, accepted or not accepted, right? So the outcomes are only two. There is no in between. So that's why the probability is divided into two, right? So in this case is the same. Yeah, it's either positive or negative. There is nothing in between. Okay, so that explains why this pie, if you see the slide over here, this pie, okay? So if let's say we want to set hypothesis, are you aware about the types of hypothesis? Null and alternative hypothesis? I forgot whether I have mentioned about this in the previous lecture or you have studied this previously. Do you know what is null hypothesis, alternative hypothesis?
I don't know.
Or you don't know? Others?
No.
You're not yet introduced to.
No, don't know.
Okay. Right. So what do you know what is hypothesis? before that, hypothesis. Do you know what hypothesis is? You're a scientist, you should know hypothesis.
Possible outcome.
Yes, correct. This one means possible outcome. So before you do any experiment, you should have ideas, some ideas about, the outcomes of your results, whether it will be, whether there will be a change, whether there will be no change, right? I mean, that is the most generic one. Yeah. Okay. So if let's say, in the case of, let's say we want to compare the data set 1 and 2 here, right? So let's say before we analyze the data, we might say that perhaps, I mean, in plain words, we can say that the data set 1 might be the same as data set 2, right? Means that there is no difference. That is one of the possible outcomes. Another possible outcome is we can say that there might be a change. There is a difference. There might be a difference. There might be a difference between data set 1 and data set 2. But that is still generic. What you mean by difference, whether data set 1 is more or data set 1 is less. So when you say it's just different, it doesn't give any idea about less or more, right? But to say that are the possible outcomes, there could be a difference, there could be no difference, right? That is what we can say hypothesis. In statistics, we divide the hypothesis into two types, which are, before we go into the notes here, let's introduce the hypothesis, can be divided into null and alternative hypothesis. Okay, the symbol for null hypothesis is H naught, we call it. O is not. And alternative, we put it as HA or H1 also here. Okay, what is meant by null hypothesis? As I said just now, null means nothing happened. You are comparing two things, but there is no change, there is no difference. So you can say that, like if let's say you mention, if you denote the data set 1 as mu1 and data set 1 is mu2, okay, you can say that the mu1 is equal to mu2 because it's the same, right? And yeah, so that is meant by here. Okay. So, but if let's say you go for alternative, you say that there is a difference, means that you can say in general, mu1 is not equal to mu2 because there is a difference. But this one is still generic, I can say. I mean, you do not know whether it can be, there are two possibilities. It can be mu1 is greater than mu2, or mu1 is less than mu2. So under the not equal to, there are two more possibilities, less or more. Okay, so basically that's the null and alternative hypothesis. Right, so that's why you see here for this one, that's how you develop the hypothesis for sign tests. You have to identify the things that you are comparing. You assign the symbols. And for the alternative hypothesis, it can be these two situations, or if you don't put it, you can just mention in general this one. Okay, not equal to. So that is alternative hypothesis. Okay, so what is this pi? This pi? So I mentioned just now that since there are two outcomes, right? Two outcomes, so means that each of the outcome has a probability of 50%, right? I mean, equal chance. You can say that, yeah, 50% could be positive, 50% could be negative, yeah? Right, so now the pi is denoted as the probability of an event of interest. So in the case of when it is equal, right? So the pi is half, or yeah, 0.5. Yeah? Because in probability we put it in the decimal point is yeah, from 0 to 1. Yeah? It's 50%. But if let's say in the case of alternative hypothesis, it's not equal, right? So the pi is no longer equal, but it can be. It depends on the alternative, whether it's less or more. It can be less than 0.5. It can be more than 0.5. Okay. So what is 0.5 here is like this one is divided into two, the probability of each of the event. Okay? Like in this one, it's not equal, so it can be maybe 30, maybe 70. So in this case, this part is less than 0.5, right? This one is more than 0.5. Okay. All right, so that is some introduction. Okay, more importantly is how to apply. What are the procedure when we want to apply this sign test? Okay, we focus on one sample first. One second. Let's go through the steps. There are 7 steps that we have to do in order to use the test and to reach the conclusion. Like I said just now, we are comparing, and at the end, you want to see whether the data sets are different, whether there is whether it's different or not. So the steps, the first one is to state the null and alternative hypothesis. So I've mentioned about null and alternative hypothesis. So basically, this step one is common. It's a common step in any statistical test. In any test, regardless, not just sign test, you have to develop the null and alternative hypothesis, because you have to predict what are the outcomes of your analysis. Okay. The second step is to decide the level of significance. So the level of significance is denoted as alpha. Okay, alpha. In a language that you can understand, is alpha is the value of the probability of error. Probability of error. So normally, like let's say when we measure something, right? We can't expect that our data, the results that we get will be 100% true, right? So we have to allow some rooms for errors because nothing is perfect. So in statistics, the range of the errors, normally we set it as 5%, 1% also possible, and 10%, there is also 10%, but the most common one is 5%. Okay, so this one can also be expressed in decimal points, like 5% is 0.05. Yeah, so this is common in statistics. Why people go for these values, I have no answer. This has been studied by statisticians for many years before, okay, and they agreed that that is the perhaps based on their observation. Yeah, the error is within that sort of range. Yeah, okay, that is the level of significance. And then step 3, what you have to do is you have the observations. You have to assign, determine the sign of difference, whereby you have to assign either positive or negative, okay, to the value. And what happens if, let's say, the values are similar? Just now I mentioned here when there is a difference between the two data observations. Yeah, let's say what happens if it's similar, 80 and 80. So you don't sign anything, right? So you just let it be without signs. Yeah. So there will be negative, positive, but and the one that is equal. Okay, right. So that is covered under step 3. So ignore those xi values that are equal. Okay. And then step 4, determine the test statistics and which test distribution to use. Okay, so this is where you have to calculate a few things, whereby you have to calculate actually the rejection region or the probability. Okay, what is meant by that? I'll go I'll go later on that. Okay, but basically, you have to refer to binomial table. I send the binomial table on Telegram, right? So there is a table called binomial, and this is how it looks like. The one that I gave is different version, different format, but it's actually the same thing. The content is the same. This one is the one, it's a bit different from the one that I sent, but the values inside is the same. Okay, so what you have to know about this binomial table, let me introduce first, and then later we'll go how to use it. Okay, so you have to know there are n. Yeah, n. N is defined as not the total number of the sample, but the one that are assigned, the total number of those values that are assigned positive and negative. Okay, I'll show later how to determine that, but that is n. Okay, and this R is the event of probability that you want to determine. Okay, and P here, okay, so there are many values, but this one, P value, is not alpha. Don't get confused. Okay, so you only have to refer to the last column over here, which is 0.5. Okay, if you see the last column on the most right, that's the value of P there is 0.5. Why P is 0.5? Because we only our case we are considering only two outcomes, remember? So the probability is actually 50-50, right? So that's why we use this last column. So what I can say, the rest of this, for this particular test, you don't consider these values. Okay, you just consider this column. But of course, because binomial table, it has other applications, right? It's not just for this. So that's why they have the values for different p values. But in this sign test, remember, we only use the last column over here. So these are the column that you are going to refer. Okay, right. So how are we going to apply all the steps, the 7 steps over here? Okay, let's have a look at one example. Okay. The breaking strength of a certain kind of rope is tested, giving the following results in appropriate units. Test whether this data indicate the mean breaking strength is more than 160 using alpha equal to 5%. So alpha here is the level of significance. So you can see that this is one sample. This is one sample. The situation here is one sample. And in this case, you have to do sign test. Yeah? So the value given to you to compare is this one, right? And you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so this sample has 10 points or 10 data that you have to compare with 160. Okay, so how are you going to do that? Okay? So to apply all the steps that we have here, okay, first one, step 1, is to state the null and alternative hypothesis. So here, you denote this one as mu, okay? And then each of these data is actually xi. Each of these data, xi, right? Okay, so step 1, to set the hypothesis. So at the end, we want to say actually whether or not the average of this sample, how it differs with 160, whether it's equal, whether it's more, or whether it's less. Okay. So the null hypothesis would say that the mu is equal to 160, right? Because there is we are comparing with 160, means that there is no difference. But for the alternative hypothesis, since it's mentioned more than, okay, that's the information that you can use to develop your alternative hypothesis. You can say that the alternative hypothesis is greater than 160. Okay, right? So those are the hypotheses. Okay, what's the second step? Step 2 is to decide the level of significance. Okay, this one is given in the question, which is the alpha value. So you don't have to decide. But if let's say it is not given, you have to define whether it's 5%, 1%, or 10%. Okay. But in this case, it's given, so you just state it as it is, 0.05. Okay. Step 3, what you have to do is determine the sign of difference. Okay, now you have to compare each of the data here with 160. So far, so good. Okay. Can you follow me at this point?
Yes.
Okay, thank you.
Nyawa-nyawa ikan, sorry.
Now, which one is not clear?
No, it's okay. It's just that maths as a whole is a nightmare for me. So never mind, carry on. All the best, doctor.
Okay, because that's the first time you see all the steps, but once you get familiarize yourself with the steps, it's fine. Okay, this is an easy test, don't worry. Okay, let's go through first. Okay, right. So the step 3 is to compare. Now your point of comparison is 160 and each of this. Okay, so when you compare 169 and 160, this one is bigger, right? 169. So you assign positive at this for this point. Okay, 163 and 160 positive. This one is positive. Okay, this one is the same. So you don't assign any sign. 189 and 189 and 160 positive. 150 and 160 negative. Right? This is negative. This is positive. This one is equal, no sign. 148 negative. Is it correct, guys?
Correct.
So that is what is meant by step 3. Determine the sign of difference. Okay, now you have to also find out here what is n. So I mentioned before, n is the total number of data with positive and negative. So although the total number of data, if you don't consider the signs, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but the n is not 10 in this case, because in this test, the n is defined as this one, total number of data with positive and negative. So 1, 2, 3, 4, 5, 6, 7, 8. So n is 8. Okay, don't get confused with the definition of n for this test. Okay, right. So n is 8. Okay, and you can see the positive sign. Number of positive is 5, right? And number of negative is 3. Okay, that is the information that you have to jot down for this step 3. Okay. Right, step 4, determine the test statistics and which test distribution to use. So know that we have to use binomial table, right? And what you are looking for. Okay, so now if I want to give an overview about this data, okay, so because statistics, we always concerned with distribution, like how is the distribution. So if we want to plot it, I do not know whether it's normal or not. Okay, so I might not draw it as a normal distribution. Maybe something like this. I don't know. Yeah. Normal. I mean, it's not symmetric, right? I say it's. So let's say from the n is 8. Yeah. Let's say I plot from 0 to 8. So this is like, the data and distribution. And what you are looking for next, after you assign the signs, we are concerned with the tail region. So when we talk about distribution, there is a tail region, right? Tail is the one that is the endpoint of it. Yeah. So the tail region. Yeah. So what we can assign here, like the number of negative, we can assign here 3, and here is 5. Okay. So meaning to say that we can find the area, we have to find the area of either side, okay, because it's actually the same. So the P from 0 to 3, okay, the P is the probability or the area under the curve, yeah, is actually equal to the P from 5 to 8. That is, that is the basic rule, yeah? Right. So what is meant by that? If you see the binomial table, do you have the binomial table with you? If I can show you, I'm sure you can. Okay, this is the one that I gave you, right? Okay. So what is the n? N is 8. So you have to consider the 8 here. So this is the rows that you have to look at. Okay. And remember, we only consider the P when it's 0.5. Okay. So if I want to write this one here, the probability that we have to look for, so we actually have to find what's the area of the tile area, which means the P when the R is 0, R is the thing that we analyze, plus P R equal to 1, plus P R equal to 2, plus P R equal to 3, which means this one, okay, this area from 0 to 3. So in order to find that area, we have to refer to the table, the binomial table. So how we're going to look at it? R is also, in this case, is X. So in the other table is denoted as R, if I'm mistaken. But it's the thing that you are analyzing at that point. I hope you understand that. Okay, this X is also equal to R. Okay, let's have a look at when n equal to 8. And you are looking for the values when in this case, it's x equal to 0, 1, 2, and 3. Okay, so what's the value that you have to look for is this one. This one, because this is 0, 1, 2, 3, right? So this is the value. So you have to jot down these values. The probability when x or r equal to 0 is 0.0039 plus 0.0313 plus 0.1094. You can refer to your own binomial table if it's so small for you to look on screen. Okay, but it's actually referring to the values that I highlighted in yellow. Okay, this one. And this one is 0.2188. So the summation of this will give the area of here, the area under the curve of this one. Okay, so what's the value over here? The summation is starts with 0 to 3, 0.0039 plus 0.3634. Okay. So just now I mentioned that the rejection region, like from 0 to 3, is actually equal to when you determine the tile area between 5 and 8. Okay, now let's see whether it's correct or not what I said. So instead of finding the area from when r or x equal to 0 to 3, we can also find the area, the probability when r is greater or equal to 5, okay? which is from 5 to 8. So this one is when P r equal to 5 plus P r equal to 6 plus P r equal to 7 plus P r equal to 8. Okay, so whether it's correct or not. Oh, this one doesn't have. Oh, okay, this one here. I highlighted in different colors. This one. This one. Okay. So it's actually the values are the same in this table. Okay. So if you put it here, when r equal to 5 is 0.2188 plus 0.1094 plus 0.0313 plus 0.0039. You can see that it's actually the same as this one, right? All of the values, because it's going in opposite direction. 0.2188, this one, and this one. So the area, the total will be the same, 0.3634. Okay? So that explains why we can determine the area or the p-value that you need to determine, yeah? Either using which tile. It's either the left tile or the right tile. But how you determine that is divided into, is based on the sign, the positive and negative sign. Like the lowest value here, you put it on the left tile, right? Like 3, yeah, 0 to 3, because we know that it starts from 0 to 3. So that is the tile area, the range of the left tile, right? And the one with the higher number, 5, and we know that is up to 8. So 5 to 8 is the range of the right tile. Okay, but we have to find only one tile. Don't sum up this. We just have to find this one, this value. Okay, but the way how you determine it is either by using left or right tile. Okay, so I hope that's clear. Okay. So back to the question. So that is step 3, right? Okay, it's not yet over. So we have still step 4 until 7. No, this is step 4. So this is step 4, whereby you determine the test density. This is step 4. The whole thing here is step 4, when you determine the P. Okay. When you determine this value, this is step 4, the P value. And now what you have to, is it 5? Actually, 4 and 5 is in this step actually. Yeah. So step 4 and 5. Sorry for that. It's actually overlap things. Right. So you have calculated the p-value that you are looking for. So what you have to do with that p-value, you have to make a decision. How you make the decision is based on this rule of thumb. If you see step 6, this is the situation that you have to refer, right? So step 6 is to make a decision. Step 6, make decision. So this p-value, okay, p is 0.3634, and you want to compare with the alpha value. Alpha value, you know, from the second step or in the equation is given 0.05, right? So you compare these two values and you accept the null hypothesis, the conditions there, accept the null if the p is greater than the alpha value, which is the case for this problem, right? The p is greater than the alpha, which is 0.3634 is greater than 0.05. So the decision that you have to make is to accept the null hypothesis. Okay, that is make decision. Okay, we're not yet over. Step 7. Excuse me. Step 7 is to make a conclusion. So how you make a conclusion, you go back to the case, to the problem that you're analyzing. You have to state it specifically. So in the first step, you set the hypothesis, and you say that when it's null hypothesis, the mu is equal to 160, right? So means that you can say the mu is 160. I mean, this is the simplest way, but you can mention it in words, right? You can see here, we accept null and conclude that there is no evidence that the mean breaking strength is more than 160, which is actually the same as when we say that the mu is 160. But sometimes there is other way to express it. There is no evidence that is. But if you say that the mean is 160, I can also accept that. So that is the 7 steps that we have to perform in order to do the sign test. Okay. Any question? Yeah. What I can conclude here is the first step, make hypothesis. Step 2 is alpha value. Step 3 is you assign positive or negative. You determine n values. You determine what's the positive, the number of positive and the number of negative, right? And then you sketch. I mean, for me, it's easier for you to sketch this kind of distribution so that you know what you are looking for, right? Because we need to find what's the tell area. Okay, this is the tell area that you are looking for, which is the P. Yeah? So that is actually step 4 and 5. Yeah? So how to determine the tell area? You have to visualize it as a which one, like here negative, there are 3, so it's from 0 to 3, right? The lowest value actually, it doesn't matter whether positive is 3 or negative is 3, right? So 0 to 3, and the other side is the one that have the other side 5, and from 5 to 8. Okay, that is actually the tell area that you are looking for, but you just determine one. But I can say that it's either one. Okay? So either way, it will give you the same value of P. And then step 6, what you have to do with that P value is you compare with the alpha value. And this rule of thumb, this one is actually in the statistics. You don't have, you cannot use other rule of thumb. This is, you have to memorize this in the exam. It will not be given with the formula. Okay, so this one, there will be lots of this kind of rule of thumbs because every test it has its own rule of thumb. So you have to remember for this, you have to remember for different tests. Okay, so based on this, you make a decision. Step 6 is about making a decision whether you accept the null or whether you accept the alternative hypothesis. So in this case, it's accept null. And step 7 is make a conclusion. You go back to your hypothesis and state the situation or the condition specifically based on that particular problem. Okay?
Excuse me, doctor, I have a question.
Yes?
May I ask what is stopping us from just taking the average of the 10 data and then calculating the mean breaking strength from there?
Yeah, so basically we want to just consider the difference. So when we take perhaps I don't know what is actually the foundation of this, but as I said, it's about making comparison, and we want to know that whether in general there is a difference or not. So that's why we ignore those points or data that do not have difference. Yeah, something like that. Did I answer your question?
Okay, sure. Thank you.
Yeah, okay. And so this one, because of this test is just about considering the signs, right? It might not be, as I said, it might not be a strong test. So you can say that there is a difference, but you do not know how much, right? Yeah, something like that.
Because if you just do the average for the sample just now,
Mm-hmm.
whether you take 10 samples or 8 samples, the answer comes around to 161.8 or 161.5, which is actually different from our conclusion by the one
Mm-hmm.
sample sign test, because
Yes,
the mean breaking strength is actually about 1 point something unit higher.
yes, yes. So when you analyze the sample or data, it's not just limited to one test. So this is one of the options, I can say. So if you use other tests, perhaps you might have something slightly different. So because of the inaccuracy of the test here, perhaps that explains the difference. That's what I can say. So every test, it has its own sort of um, principles. So in this test, the principle is about considering uh, the difference. So that's why it ignores those that do not have the difference. Okay, I know that there might be some confusion why this one gives different conclusion, but as I said, if let's say in the real practice, if let's say you find out that um, other type of tests, yeah, might give you a better or more accurate answer, so hence this test might not be suitable. You know what I mean? You have at the end we have other options actually. So this is just to introduce you one of the options of the statistical test. It might not be the best, it might not be the most accurate, but in some situations, if let's say we want to have a quick um, comparison or quick analysis, perhaps it might be suitable for that kind of situation. Okay. Okay.
Okay, sure.
Who asked me just now? Abraham.
Abraham Chor, yes. Nice to meet you.
All right. Okay. So yeah, so that is example one. Yeah, I have another one example here. I'm not sure whether I have enough time. Maybe you can go through by yourself because the principle is the same. You apply the 7 steps. Like actually it's the same. It's just different situation. Okay. So I let the things for you to go through by yourself. Okay, let's go directly to left tell or two tell tests. Okay. Right. So what is meant by left tell or two tell test? Okay, just now, if we refer to the problem, okay, it is given in the question, uh, the situation or the specific condition, right? More than 160. So that is actually the hint uh, for you to develop the alternative hypothesis to say that okay, the alternative is more than 160. Okay, remember when I say the alternative hypothesis, it can be where is this? Okay, it can be this form. It can be like the generic form, the general form. It can be just not equal. So we don't have ideas whether it's more or less. Okay. So in what situation we use we develop the alternative hypothesis by using the not equal sign, and in what situation we use specific signs like this one. Okay. So this one is actually what we call two-tell situation, two-tell situation. And this one is actually one-tell situation, one-tell, one-tell. Okay? Okay, so that brings me to this one. left tail or two tail. Yeah. So how you know is based on how to know which. Based on the problems. Okay? I cannot say that in all cases you have to apply two tail, or in all cases you have to apply one tail, but it depends on the problems. Okay, let's see what kind of problems that require two tail and what problems require one tail based on the problems. Okay. So just now is basically this one. The first example that we discussed now is actually one tail. Okay, because of the alternative hypothesis we set greater than 160. Okay, if let's say we go to which one? A situation where, okay, like this one, just have a look at the words that I want to emphasize. Huh? Right, so this is quite simple. We're going to discuss later, but I want you to see how the points are mentioned here. Determine whether these data indicate that one line produces more defectives than the other. Okay, so now basically there are two production lines, A and B, right? Right, so this is actually the keyword that indicates that this data need to be analyzed by using two-tailed test. Okay, so what does it mean? So because we do not know that, it says that one line produces more defectives than the other. So it doesn't mention A is greater than B or B is greater than A or what, okay? So this is where in the alternative hypothesis, if you can see here, right? The alternative hypothesis, we use the sign not equal because we have no idea about what actually is, which one is greater or less than. Okay, so this is an example of two-tailed test. Okay, so the difference between one-tailed and two-tailed test is that just now, as I said in this example, we just only consider one tail, right? It's either the left tail or the right tail, and because they are equal, so we can use either one, right? But we cannot use both because this is, yeah, because of, I forgot to mention, because this one is one tail. That's why we use one tail only. But what happened if, let's say, our alternative hypothesis, if we set it is not equal to 160, let's say, in that case, we have to consider both tails. So instead of just taking the value of 0.3634, you have to actually multiply it by 2, which is, now the P should be 0.3634 multiplied by 2 because it's equal, right? Both tails. So the tail area will be double. It's not half. Yeah? So that's the only difference between one tail and two tail. Actually, two tail test. The rest is actually the same. And how to know? As I said, based on the problems. Okay. So that explains this subtopic. It's not much actually. It's just to emphasize on one tail or two tail. Okay. So extra notes on one sample sign test. What happened when n is greater or equal to 25? Okay, so in most of the problems, just now if you see the n is not less than, not more than 25, it's less than 25. The n is just now is 8, is it? So the n is refers to the number of positive and negative. So when the n is greater than 25, what you have, the difference is that you have to use normal distribution in order to determine the probability or the area under the curve. So just now we used binomial table, right? Because the rule is when it is less than 25, we use binomial table. When it is more than 25, we use normal distribution. But this will not be emphasized much in a non-parametric test because we are going to cover that more in parametric test. So this is just for your information. So when n is greater than 25, we don't use binomial distribution anymore to determine the p-value, but we use the z distribution, the normal distribution, whereby we use this formula to find the z, and from the z value, you know what's the area under the curve using the normal distribution. Okay. I think this is just for your information, not to be applied. We don't ask this kind of questions. So this is this normal distribution. So this distribution is actually for you to find the area under the curve. Yeah? So like this one, if you use the normal, so these are the values. First, you have to know the z value. That's why there is this formula. So based on that z value, you can determine the area of what the z enclosure. Okay. So I have a homework for you to do here. Okay, I hope that you understand all the 7 steps of one sample sign test, right? So this is an exercise for you to do at home. Okay, let's move to the last part, which is PET sample sign test. PET sample sign test. Okay, PET sample sign test can be applied to PET data to test whether two normal populations that are dependent have the same mean or not. Okay, so the difference between, just now we are talking about just one sample, right? So for PET sample, there are actually 2 samples, but that 2 samples represent 2 populations. Okay, so the rules, the procedure is actually the same, but it's just that the problems will be different. I mean, the problems will, you would have two samples of data that comes from 2 population. Okay, right. I can say the procedure is the same actually from step 1 to step 7. So let's have a look directly at the problem. Okay. So the number of defective items produced by 2 production lines, A and B, was recorded for 8 days, right? So this is an example of PET sample data. Assuming that A and B have the same distributions, determine whether these data indicate that one line produces more defectives than the other, okay, at about 5% level of significance. So I mentioned that this is a two-tail test because of this statement. More one line produces more defectives than the other. If let's say it says that A determine the data whether the data indicate that A produces more defectives than B. In that situation, it's one tail because we know what is greater than what. Okay, but in this case, it's two tail. Okay, let's go directly to the solution. Yeah, the steps are the same. The first step is to set the hypothesis. So these are the hypothesis sets. Right, you are comparing now data of production lines A and production lines B. Okay? There are 2 things that you are comparing. So the hypothesis is when the null, it says that there is no difference, and we represent the data as mu, or the mean of the average. So that's why you note here as mu. And for the alternative is not equal. I've thought about it. And step 2, okay, step 2 is given 5%, so you don't have to, but you just have to write it 0.05. Step 3 is to assign the signs, whether positive or negative. Okay, now you are comparing the 2 data, right? So this is data for A, and this is the data for B. So how you want to know you want to compare from what point? Like what I mean is like if you compare from the point of view from the point A, like from this point, 172 is less than 201, right? And it should be negative, but here it says positive. So you have to be consistent throughout your comparison. Okay, if you choose A as the point of your comparison, I hope you got what I mean by this. When you compare from the point of view A, like 172 and 201, 172 is less than 201. So you assign this one as negative. So you have to be consistent throughout the observations. Means that from day 1 until day 8, you have to stick with A as the point where you compare. Okay, so that the signs will not be mixed up. Okay, so if let's say I compare from the point of E, okay, 201 is greater than 172, so that's why in this case it's positive. Okay, so let's go through it. If let's say from using B as the point of comparison, 179 is greater than 165, positive, right? 159 is less than 206, negative, and so on until the end. Okay, 182 is less than 201, that's why this one is negative. So that is when you are looking from B. If you are looking from A, it will be the opposite, right? Because this one will be negative, this one is positive, negative, 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 positive. So actually, it doesn't matter which point, either from, in this case, either from A or either point B, but the rule is you have to be consistent. Don't compare like half of the way you compare from the point of P. So it will give you wrong signs. Yeah? Okay, why I say it doesn't matter, because at the end, as I said, it will be about the tell. It will be like, for example, yeah. So let's say you just go through first. Okay, let's say we use the original data here, which is from the point of B. Okay. So means that the n here is 8 because all have signs, right? And the number of positive, if you are using this one, these values, the number of positive is 1, 2, 3, 4, 5, 6. Is 6. So the number of negative is 2, right? So if you want to sketch it, okay, you start from 0, then start, like this is the lowest value is 2, and here is 6, and it's up to 8, right? So this is the area that you are looking for. So this is case 1, when you compare from the point of B. What happens if you compare from the A point? Yeah, the case 2. It will give you the same, actually the same overview. Case 2, yeah, like this one. And number of positive is 2, and number of negative is, it's opposite to the first case, is 8, right? So it's actually the same thing. You are looking for the region, like you sketch from 0 to 2, because this is the lowest value, and here is from 8 to, and from 6 to 8. It's the same thing. So that's why it doesn't matter. But as long as you are consistent, as I said. Okay. Right, so what are the next steps now? Let's go back to the steps. You assign the signs and then you determine the p value. So how you determine the p value? You use the binomial table, right? Binomial. So you are looking for the probability when r equal to 0. Okay, now remember this is two-tailed test, right? This is two-tailed test. So this is what you have to take note. Okay. So means that you have to calculate both areas of the tails. This one plus this one. Okay. So, but since they are actually the same, you just determine one and then you multiply by 2. Okay. So you just choose one tail, P equal to R, yeah, plus PR equal to 1 plus PR equal to 2. Right. So if you refer to the binomial table, the n is 8. Okay, it's actually from the same here. 0.0039 plus 0.0313 plus 0.1094. Okay, so the value is 0.1446. Yeah, since it is two-tailed test based on your alternative hypothesis, so you have to multiply by 2. So 2 times P is equal to 2 times 0.1446. Let's give you the value of 0.2892. So that is your P value. Okay, right. So what's next? So this one here. Okay. Next you have to compare it. The rest is actually the same. We compare with the alpha value, yeah, for you to make the decision. Since P is equal to 2892, alpha is 0.05. So the P is greater than alpha. So based on the rule of thumb, we have to accept the null hypothesis. Right? Okay. I hope that you are still with me. This is in the step here. Where is it? Yeah, here. Step 6. This is step 6. Okay. So I made this decision based on this one. Okay, so accept. And step 7 is to make conclusion. Okay, so to make conclusion, we have to go back to the question. We have to go back to the problem and state the thing specifically. Okay, so in this case, what is our null hypothesis? Is the null hypothesis is the null hypothesis is this one. The mu A is equal to mu B. So means that the number of defective items, you can put it in words, the number of defective items produced by production line A is equal to that produced by production line B. Or in other way, you can also say that there is no difference, also means the same. So either way, I will accept it. But if there is no difference, you can also say that there is no difference between this one, all these things, defective items produced by A and B. Okay, the reason why it's very important to state the conclusion specifically, why don't we just left accept it now? Does it? Why it's not like that? It's because in you apply the statistics in analyzing your data, your perhaps later your FYP data, your biotech research. So you cannot just tell people that you accept the null hypothesis. People do not know what is your null hypothesis. People don't know your alternative hypothesis. So that's why it's very important to write the conclusion properly. Yeah? So you relate back to your experiment. What are the things that you are analyzing? So that makes sense. Yeah, and this is what you have to apply in your research writing, in your FYP, final year project, when you are in third year. So you write the thesis, you have to write proper conclusion. You cannot say just accept what, I do not know what's your alternative, what's your null hypothesis. Okay, so that's why this step, the final step, it looks like, you know, it might not look important, but it's actually very important. Okay. So that is PET samples. So in terms of the principles, it's the same. It's just that the data are different. You can see that the steps are actually the same, like if you are analyzing one sample under this sample test. Okay, problem example. And there's another example, but please go through by yourself. It's actually the same thing, but it's just different problems. Yeah, but yeah, the steps are all the same. So I hope that you can go through by yourself. Problem example 3 as well. So under this PET sample sign test, there is another problem that perhaps you can try at home. Yeah, homework 2. So just now is I put it homework 1. This is another problem that you can try and get to familiarize yourself with all the 7 steps. How to use the binomial table and how to analyze the data, whether it's single tell, one tell, or two tell test. Okay, so I hope that you can do by yourself. The 2 problems here, homework 1 and homework 2. Okay, so that's it for today. So basically we have covered sign tests. Sign tests, yeah. So this is one of the non-parametric tests. It's not the only one. I mean, there are many tests that you're going to cover, and this is one of it. Yeah. So the basic thing that you have to understand is that statistical tests in general is about making comparisons. Okay, and the things that you want to compare, it depends. So it could be only one sample. It can be 2 samples. Yeah. So that is the data. And for the sign test, you have to know all these 7 steps. Yeah? All the 7 steps, yeah. And how to find the P. The P is the probability that you want to compare with the alpha value, as mentioned here. And how to use the binomial table. So as I said just now, this is binomial table. You have to know what is N. Don't get confused with the total number. N is the total number of positive and negative only. Okay. And then the R here is the things that you want to analyze. Okay. Or X in the other table. And you only refer to the last column where P is equal to 0.5, because here we only talk about 2 outcomes, positive and negative. So the P is set at 0.5. So that's why I use the last column. So the rest of it is not used, but perhaps if they are used for other applications, but not for sign tests. Okay. So that's it for today. Any question before we discuss?
Yes, doctor, may I ask?
Yes.
For the second question just now, case number 2, number of positive and number of negative in your writing on
Okay.
the bit where there are green graphs, number of negative is actually equal to 6, right? Not 8.
Which one? Oh, the one that I give example? Oh,
Yeah,
yeah,
this one.
correct. Yes, sorry for that. Yeah, thank you for highlighting it. Yes, I'm quite confused. This is 6, yes. Correct.
Right. Thank you, doctor.
Sorry, yeah. Yeah, this is 6
okay.
to 8. Okay, I hope that's clear. Yeah, I got
All
confused.
right.
with the
Thank you,
and.
doctor.
All right, welcome. Any more questions before we discuss? So you need to practice a lot. Yeah, this is a calculation subject. So the more you practice, the better. Yeah, practice makes perfect. If let's say you want to practice more, you can find the questions from the internet. Okay. We don't have textbook, specific textbook. So that's the difference between uh, the way how you study at school and university or matriculation before center. So at the university, you have to be independent. You have to find by yourself most of the things. Okay. So if let's say it's not enough, maybe you need to study more, you need to practice more, you have to find from the internet. Okay. But anything you can ask me. If let's say you're not clear of some of the problems you want to ask, then you can email me. Okay. But we don't have some sort of latih tubi ke macam kat sekolah, tak ada. Okay. So you have to differentiate lah. That is the difference between studying at university and studying at school. Right? Okay, so if there's no more question, yeah, I will record some of those who need the manual attendance. Yeah, don't worry. And for the ELIP, I've posted tutorial 1. Okay, I hope that you aware about that. Tutorial 1. Okay, submission of tutorial 1. The deadline is 8 April. Yeah. So yeah, the assignment of groups, I make it here. So you have to do in a group. Yeah? Discuss with your friends and submit only one tutorial. You assign one representative to submit your tutorial on ELIP. Okay. Oh, I forgot to share. So let's see. Yeah, this one. Tutorial 1. Okay. I will record the attendance. Okay, guys. So that's it for today. Thank you for your attention and attendance. I'll see you guys in next week. Okay, have a nice day. Stay safe.
Yeah, doctor.